Hello, and welcome to the webinar for the MQTT for the Internet of Smaller Things, the standardization of MQTT-SN. We have three speakers today, myself, Ian Craggs, Simon Johnson, and Dominic Ohma. Before we start directly, then we'll have a quick introduction to OASIS, the standards body, and the programs that it includes.
Hey folks, and welcome. Hey, and welcome to the webinar. This is Dee Sher with OASIS. Just very quickly, some of you are familiar with OASIS and some are not. OASIS is a well-established, widely known international standards organization. OASIS offers projects, including open source projects, a path to standardization, and de jure approval for reference in international policy and procedures. There are a variety of ways to engage with OASIS through traditional technical committees like MQTT-SN that we're going to hear about this morning, also open source projects. Additionally, if some of you and your colleagues are considering establishing a foundation to advance a technical agenda, we would like to speak with you. As some of you may know, OASIS has a long-standing relationship with ANSI. We support the work of the U.S. technical advisory groups that advance ISO standards. And with that, I'll turn it back to Ian.
Thanks, Dee. So I'm Ian Craggs. I'm co-chair of the MQTT-SN subcommittee at OASIS. I'm also the project lead of Eclipse PAHO, which deals with MQTT and MQTT-SN software. A bit of background about MQTT, first of all. MQTT was first devised in the late 1990s to solve the problem of monitoring an oil pipeline in remote locations. The communications was over satellite links, low bandwidth and expensive, and the first implementations were with polling of the concentrators and devices from the central server, which resulted in the central server being CPU bound. With the implementation of MQTT, the solution became much more efficient. Messages were sent from the server to the concentrators only when needed, and only when events of note occurred, so that the whole solution was much more efficient. As a result, the MQTT specification was published by IBM openly and with no restrictions on use, so that it could be implemented by devices of all sorts. There was no way that any one particular supplier was going to be able to implement solutions for all possible devices that were available. So there are a number of design principles that MQTT was conforming to. It needed to be reliable for those satellite links and remote locations. Rather than reproduce the reliability characteristics of TCP/IP, it was decided to use TCP/IP itself. It needed to be industry agnostic, so for that reason, the message payload was not specified. You can put in any data that you like. It needed to be lightweight and efficient to minimize any overhead on those satellite links that were costly to send data. Simple to use and implement. Applications needed to be small as possible and power efficient as they could be over TCP/IP, and to provide maximal flexibility in solutions. A loose coupling between senders and receivers chosen, so that meant a publish-subscribe messaging model. Even though the specification was open and freely implementable, it was still under the control of one company, IBM. To make it even more acceptable in a wide variety of solutions, standardization was needed. And OASIS was chosen as a standards body as IBM and OASIS had a long history of collaboration. The first goal of standardization was to create minimal impact to existing implementations. And as a result, the MQTT 3.1.1 standard was published in October 2014. But that left many outstanding issues that we wanted to address. And so right away, we embarked on the next version of MQTT. There were several themes to this: scalability, improved error reporting, the capability of adding metadata to the information in packets, extra support for resource constrained clients, and more support for higher performance. The result of this work was the MQTT 5.0 standard, which was published in March of last year. But one of the major outstanding questions that we hadn't addressed was the applicability to non-TCP networks. And this is where MQTT-SN comes in. MQTT-SN was first devised and published in 2008. The goal of MQTT-SN is to provide a publish subscribe messaging paradigm similar to MQTT over, in the first instance, wireless sensor networks, with a gateway in between the MQTT part and the MQTT-SN part.
Ian, can you pause for 1 second? We are, it doesn't seem as if the attendees can hear. I'm having some feedback on audio.
Okay.
And for some reason, I'm not able to interact to, okay, so other folks are telling me they hear fine. Okay, great. I'm sorry for the interruption. Thanks so much. Carry on, Ian. Sorry about that.
Okay. So this is a short timeline of the development of MQTT-SN in parallel with MQTT 3.1.1. And a quick comparison between MQTT and MQTT-SN. So MQTT uses the reliability characteristics of TCP/IP. MQTT-SN is designed to run over a connectionless protocol that provides error-free datagrams. So it still needs the error correction in the underlying transport. UDP is typical, and ZigBee was another example of that. Encryption is not supplied by MQTT-SN, as it's not supplied with MQTT. It again relies on the underlying transport. But with UDP, for instance, we could use DTLS. Both MQTT and MQTT-SN use a publish-subscribe messaging model, but in MQTT-SN, there's also a peer-to-peer messaging model using multicast. MQTT-SN has extra capabilities for power saving with the client sleep mode. MQTT-SN has a smaller maximum message size and an extra quality of service for publishing messages of -1, which again uses the multicast capability. There are two typical types of gateway to interface between MQTT and MQTT-SN, a transparent gateway and an aggregating gateway. The transparent gateway creates an MQTT connection for every incoming MQTT-SN connection. This provides visibility of the MQTT-SN clients at the MQTT server. The aggregating gateway collects all the incoming MQTT-SN traffic into one MQTT connection, thus providing extra efficiency between the gateway and the broker, but perhaps less manageability of the individual MQTT-SN clients. Both have different advantages. Some related technologies to MQTT-SN are CoAP, a protocol which targets similar applications, but uses an HTTP-like messaging model rather than publish-subscribe. There's lightweight M2M, a device management protocol, which is frequently used with CoAP. We have considered some MQTT-SN implementations of lightweight M2M in the past, but I'm not sure any have actually been finished. Obviously, MQTT-SN is intended to cooperate well with MQTT, and the original underlying transports used with MQTT-SN were UDP and ZigBee. But in today's world, we're talking about low power, wide area networks, Bluetooth low energy, and still UDP. And now I'll hand you over to Simon Johnson.
Hi folks, great to see such a great turnout. My name is Simon Johnson and I'm Principal Engineer at u-blox. I was lucky enough to be part of the very capable team that created ThingStream, which was acquired by u-blox in March of this year. I'm going to tell you a little bit about how we have used MQTT-SN in our projects and how it's helped us crack a lot of the problems that our customers have been facing. But first of all, I'll tell you a little bit about us and who we are. So u-blox is a Swiss company that provides the building blocks that make the Internet of Things a reality. We make chips and modules, providing wireless communication and positioning for automotive, consumer and industrial markets. We've got a broad service portfolio, including communication, security and location, all of which we deliver as a service. And it's our u-blox MQTT Anywhere product, which is what we're going to be talking about today, and it's our MQTT-SN gateway, and we think it's the world's largest commercial gateway, unless otherwise people can tell us otherwise. So we got involved with MQTT and MQTT-SN when we were first investigating different approaches to solving our customer problems. We were finding teams struggling with the same challenges, which was stopping them moving from ideation and POC through to commercial deployment of their projects. The main concerns are listed here, but chief amongst them are the need for devices to be low power and low cost. We needed to come up with a solution which addressed the need for a device to be out in the field for months and years at a time, with minimum associated maintenance and data costs. Vendors are using the total cost of ownership in their revenue calculations, which is based on increasingly longer life. And in these projections, the secondary and operational costs can become prohibitive to a large-scale commercial rollout. So there's a lot of work that goes in from our customers to keeping operational costs low and data charges to a minimum. It was essentially our job to find a low power, low cost solution to help these customers get beyond the POC, which is where we see a lot of the projects stall. So massively oversimplified, the problem's simple enough. Power usage on these devices is a function of time on processor and the time the radio stack is up. And operational costs are a function of the number of bytes sent across the network. So coming up with a solution which limits both of these things was the challenge. We needed to find a protocol and networking stack that allowed us to do this. As it turns out, MQTT-SN was the obvious choice. As you can see from the matrix, and I don't have time to go into each point in detail, but our customers' demands are met either directly or indirectly by the protocol itself. I'm going to mention two of the features that MQTT-SN that were real game changers for us in terms of adding value to our customers' development toolset. That is sleeping client and quality of service -1. We have customers with fleets of tens of thousands of units using quality of service -1 to send tracking information without the need to have a full MQTT session on the broker and all that goes along with that. This alone saves 4 protocol messages per interaction with the broker, which over the lifetime of a device really adds up. And these kind of data savings, when you look at the lifetime projection calculation, make it really easy for vendors to see exactly what they're saving and where. Many of our customers employ the sleep cycle to preserve their battery life. They're able to make huge power savings by sending the device into deep sleep while having sleeping sessions on the broker, maintaining their state. They can choose to wake up and receive their messages or simply publish to quality of service -1 directly from a sleeping session itself. And this fire and forget metaphor is simple and massively effective. We've had customer feedback that being able to simply send a quality of service -1 message when waking from a deep sleep without having to bring up an entire TCP stack for a full data connection is somewhere in the order of 5 times more efficient when using our SDK. And they're the kind of savings that make the customer stand up and notice. When we introduce our customers to the concepts of quality of service -1 and disconnected sleeping sessions, they really begin to understand the power that this gives them when they're designing their data handling routines. In fact, one of our customers, Versa Design, employs some of these techniques and has recently announced their VTrack global tracking product, which has a 10-year battery life commitment, and we're super proud of that. In creating our MQTT-SN gateway and implementing the specification as it sits today, it became clear that there are a few bits we would like to see added and reviewed as part of the standardization effort. And we are presently actively engaged in this work with Ian and others. u-blox are committed to contributing back to the open source, and we see the technical committee's work as hugely important. We're already discussing and collaborating on creating more open source artifacts around the next iteration of MQTT-SN, and we would like to see a thriving community. I'd like to actively encourage those who are interested in contributing or have feedback or ideas of MQTT-SN or MQTT more generally to get involved with the technical committee, either through OASIS membership or via feedback to the committee itself. We're really happy to engage. And with that, I'd like to hand over to Dominic from HiveMQ.
So thank you, Simon. Let me introduce myself. My name is Dominic Ohma. I am the founder and CTO here at HiveMQ. And at HiveMQ, we really focus on MQTT. So for people not familiar with HiveMQ, HiveMQ is an enterprise-grade MQTT broker, which operates at massive scale. So we have customers operating more than 10 million devices over MQTT, which we have seen use as TCP connections. And so in general, we as a company, we strive to providing high quality and production grade MQTT software, which is on the one side, the MQTT broker, HiveMQ itself, which is available as a commercial edition, but also as an open source edition. And we create things like open source MQTT libraries, like Java libraries we developed with BMW Car IT here in Germany. And we open source regularly things like MQTT tools. So for example, we create tools like command line interfaces. We recently released a test containers project, which makes it easy for people using MQTT inside the projects. So, and we also have a cloud service which really focuses on MQTT. So, but the thing here is, how does MQTT-SN play into all of this? So as it is right now, HiveMQ is operated by our customers or by us, usually on data centers, and with these MQTT clients which connect over TCP and MQTT to the platform. And then HiveMQ integrates with a lot of other systems and literally any enterprise system. So, but over the years, we saw that MQTT-SN might be a very good addition, and for a lot of customer use cases, a protocol like MQTT-SN would be really beneficial. Because if you look at MQTT, MQTT is really a perfect choice as a protocol for TCP-based networks. So namely cellular networks, so especially 2G to 5G networks. This is where MQTT really works pretty well. And we have customers worldwide deploying extremely large scale deployments based on cellular networks. So MQTT also in local area networks, but also wide area networks, MQTT usually really works pretty good. And also we see nowadays that even inside cars where automotive Ethernet is available, intra-car communication also happens over MQTT over TCP. But if we look at this low power wide area networks, which we have when we look at LoRaWAN or when we look at narrowband IoT, then MQTT and TCP really has some shortcomings. And this is where we see as HiveMQ that MQTT-SN really fills the gap here. And we have a lot of customers who are interested in this. And as Simon already pointed out, that things where battery life is at a premium, MQTT-SN is really an extremely good solution. And MQTT itself might, even although it's one of the most lightweight protocols out there for IoT communication, MQTT might still be a bit too bloated if you're focusing on things like quality service -1, this fire and forget semantics, which Simon also explained. This is really where MQTT-SN plays into this. And also, if we look at these low-range wireless personal area networks, which usually have locally or these mesh networks, then MQTT is really not the best choice always. And this is actually where MQTT originated. So if you have like IEEE 802.15.4 networks like 6B, or if you have 6LoWPAN in the play, then MQTT-SN is really a very good choice. Because as Ian pointed out, there is this gateway architecture. So you have usually your MQTT-SN network and then you have a gateway which translates to MQTT. So it's really, for us, we really see it's complementary to each other, these two technologies. And for us, it's very important also to be part of this. So we help with standardizing here at OASIS MQTT3 and MQTT5. And now we're also actively participating in MQTT-SN. And also we see a lot of customer interest already in this new standardization. So we are committed to participating in creating a thriving MQTT-SN open source ecosystem, because it's like this hen and egg problem. So if there is no standard, there are no implementations, and so on. And we really want to contribute by creating a standard and also creating a thriving ecosystem, so companies have open source libraries available. And as I already told you, our customers usually are already using this low power wide area networks, and first class MQTT-SN integration is something a lot of customers are urging us to do, and this is something we really see a lot of value also in providing high quality implementations which are commercially great and can be used in enterprise environments. So this is also something we are committed to do in the future. And we really want to create this ecosystem and help. And I'm also actively ask you here in the audience if you're interested in all of this. So there are a lot of ways to contribute to MQTT-SN standardization. This is something Ian will talk about.
Thanks, Dominic. So at the end of last year, in 2019, we formed a subcommittee of the main MQTT technical committee to start the standardization of MQTT-SN. We hope to have a draft proposal out later this year and hope that we can complete the standardization of MQTT-SN sometime in the middle of next year. The starting point is the current 1.2 specification of MQTT-SN published by IBM, and there's a public mailing list where you can add feedback and comments. We have several starting points for changes that we'd like to make. So Simon has written up some implementation notes that were collected during ThingStream's implementation of MQTT-SN. Dominic has talked to several implementers or prospective implementers of MQTT-SN and collected those thoughts together. I've written a document about how MQTT-SN can be aligned with MQTT version 5 because it was written or devised during the MQTT 3.1.1 timeframe, and there are several advances and changes and improvements to be made to MQTT version 5, which we want to incorporate into MQTT-SN. There's several implementations of MQTT-SN, including in PAHO, that we take advantage of comments from and experiences from, and also from the comment lists. We've had several useful additions from there also. Some common themes have arisen while we've been gathering this information. We need to retain the simplicity and flexibility that already exists in MQTT and MQTT-SN. So when we ever add a new capability, we still need to keep in mind that it needs to be as simple and as efficient as possible. We want to align with MQTT version 5 rather than 3.1.1.1 because MQTT version 5 is the future. We need to be aware of power consumption because that's a key issue for using MQTT-SN. So any improvements that we can make in that area are crucial. MQTT-SN at the moment doesn't include any authentication. And so we've had a few comments about authentication. We may well include some capability for that. Encryption, we're not likely to include encryption in the protocol itself in the same way that MQTT does not include encryption, but rather rely on an external capability like DTLS for UDP. But at the very least, we should include some implementation guidelines in the standard, and that's what we intend to do. You can find the list of issues that we're currently working on at that URL at the bottom of the page if you're interested. One of the other comments that we've had is that there isn't so much of an MQTT-SN community as there is around MQTT. And that's not surprising because MQTT has been around for longer, has more implementations, and has been standardized since 2013. So standardization of MQTT-SN is a key part of increasing the community and helping people adopt it. There are already some open source implementations, both in Eclipse Paho and other projects on GitHub, which you can find with that search. But also, if you are anticipating or interested in using MQTT-SN or the products of the communities, both the standards and the open source software, then communities are only as good as the participation of the people involved. So we call on you, interested people, to participate as well as use the products of the open source and open standards bodies. Contributions can take the form of time and effort, people, or contributions of software, documentation, tests and fixes, or donations. Time and effort is probably the most important and useful aspect. So for OASIS, you can find out more at the URL at the bottom of the page and how to join. To follow the progress of MQTT-SN standardization, you can look at the links at the top of the page and you can add your own comments to the mailing list. And thank you, that's all we have for you today. And now we'll take some Q&A.
Great job, guys. You are spot on with the time. So we do have a couple minutes. I have a lot of questions. I'm trying to group them, but rest assured, if we don't get to them, and of course, feel free to drop off whenever you'd like, we will follow up. I'm going to get all of the questions documented, so don't worry about that. I promise you we'll follow up one way or the other. So let's start with this significant question, I think, how to scale SN up to using the AWS IoT Hub. Ian, you want to take that one?
Sure. I get asked this question regularly, and for cloud platforms, I think the main way of connecting in for MQTT-SN devices is to use an MQTT gateway. So TCP is the route to connect to these platforms over the internet, and MQTT-SN should be used at the edge, connecting into a gateway, and then using MQTT to have that connection to the central platform. I don't think that central cloud platforms should be implementing MQTT-SN itself. I don't know if Simon or Dominic have any other views on that.
Well, of course, you could always use ThingStream, u-blox ThingStream to get your data into AWS via our SN gateway. So at the moment, there's no open source gateways available. I think watch this space on that one. But as Ian said, it's going to be via a gateway.
Yeah, and this is a great point. So I'm also not aware that any open source implementations are out there which can be used right now. So I think something like the u-blox gateway might be a good choice for doing this. And this is because, but usually for other vendors, standard MQTT-SN to MQTT gateway would be sufficient. In case of AWS and Microsoft Azure, you might need a specific gateway for this because they don't implement the MQTT standard fully, but only a subset. So there might be some code involved or some vendor product like Simon pointed out. But for platforms who are using 100% MQTT, you can use usually any MQTT-SN gateway.
I will emphasize there is an MQTT-SN gateway in Paho that targets UDP and ZigBee, so that there is a link in the presentation to that.
Okay, great. So I've had a lot of questions about comparing SN to CoAP, why you would choose MQTT-SN over CoAP. I know you touched on it, Ian, but it looks like folks are interested in more depth there.
Yep. So my view is that it's about the messaging paradigm, so that it is a similar way of constructing the application to MQTT, whereas CoAP is oriented around or designed in a similar way to HTTP. So I think it's about the messaging paradigm that you prefer to use. I think there are some other characteristics of comparisons, but I'm not sure in detail of what they are. And that's something I think that we could be looking at, because I think that's going to be useful information. I wonder, Simon, do you have any?
Well, I think it's an interesting question, and one that I get asked as well. It's each on the merits really, and it's often is going to be use case driven. The SN or MQTT and MQTT-SN is a data centric paradigm, as Ian said, messaging based, and it has it has obvious uses, and it's similarly CoAP on an application level. You can see use cases that would be potentially better aligned using CoAP. So I think each has its own merits is what to say, basically.
Might be useful for us to add some comments on that in any implementation guidance that we provide.
Absolutely, yeah.
Okay, so there are a lot of like really specific that I'm not sure has really wide application. Here's a more broader question. Should we expect many changes as part of the standardization effort?
So we're not going to make gratuitous changes. So we'll try and make as few as possible, but I think that in the discussions we've had so far, we feel that there are a raft of changes that we definitely need to make. So in the end, there might be some significant updates, but we're not going to make them for the sake of it.
So one of the defining things we have in this, as Ian alluded to earlier, is alignment against the MQTT5 protocol. That brought some features from SN into TT, and it will make sense that when we produce this protocol for SN, that there is good alignment between those two standards.
Yeah, I'll just add on that point. There's been quite a lot of discussion, and I think there are some 30 tickets that we're currently reviewing and deciding what's going to make the cut and what's going to go into the standardization effort, and they generally relate to either general V5 alignment topics or pieces like auth and topic negotiation, which just needs to be defined a bit clearer, a bit more clearly. So yeah, not wholesale changes, I think. Don't expect wholesale changes, but certainly we're going to flesh things out a bit.
Okay, a couple really interesting questions. How about LoRaWAN? Am I saying that right?
LoRaWAN.
There we go. Or even the Things Network. Any thoughts on their first movers advantage?
I don't know whether Dominic, do you want to speak to that, or?
So this is an interesting question. So I'm not sure about the first mover advantage here, actually. So I cannot speak to this. So this might be something, I guess, for analysts. But I'm not sure about the first mover advantage here. So in general, LoRaWAN is a low power wide area network technology, is perfectly suited for carrying MQTT-SN, and so yeah, I think from a technology perspective, MQTT-SN works beautifully with LoRaWAN. About let's say the business side of this, this is something I cannot comment on.
I think the Things Network do use MQTT messaging as well, so I think it's an MQTT-SN wasn't a capability that was standardized and available for use at the time frame that Things Network was getting started. So the the fact that we're standardizing MQTT-SN now would make a potential change in the decisions that people adopt. And that's what we hope to achieve. One of the things we hope to achieve by the standardization of MQTT-SN.
Okay. How do you see device management on top of SN? There is no standard and it's proprietary, right?
I'm not sure what is proprietary. Obviously, the standards that we're talking about is going to make it the specification of MQTT-SN open and not owned by any particular company. So that's not going to be proprietary. But we've talked about in the past potentially using lightweight M2M, a form of that over MQTT-SN for device management. And so that's a possibility. But so far, that's not something that we've had come up as a pressing issue. Simon, is that something that you guys have talked about?
The whole area of device management is a big topic, but I think it's sort of beyond the scope of the SN, our current work in the SN committee as it stands today. But it's an interesting topic nonetheless, for sure.
Yeah, as I said, it's definitely outside the scope of what we do here. Same in MQTT, we didn't define anything there for that, but there's projects like the Eclipse Cura project. They built a remote device management system on top of MQTT. I imagine that people will do similar things here. It'd be probably unreasonable to try and put something in the spec itself.
I think it's in the spirit of MQTT and MQTT-SN not to bite off areas that are not directly applicable to the core of the use case of the protocol, but leave those aspects to elsewhere. But certainly we don't want to inhibit cooperation with other standards or protocols. So I think that's something that we'll think about and investigate as time goes on.
Okay, I like that answer. So we're past the time. Let me just ask one more question. I can't find it. I don't know if they withdrew it, but I thought it was a really good question. Do we see MQTT-SN widespread industrial use? Is that a vision that we have?
So my view is yes. I hope that will definitely be the case. Simon and Dominic, what do you think?
Yeah, absolutely. So especially so, I don't think MQTT-SN will replace MQTT at all. It's really complementary from what we see, but it really helps extend the reach of these MQTT networks also to this mesh networks, to this local networks, to these networks who really run only locally, but also if you look at this low power wide area networks, which we also talked about today, MQTT-SN is really a great choice here, especially when it comes to things like battery life. I do think, and this is what I've heard of the customer discussions we had, is that MQTT-SN and MQTT will really reside to each other, and both protocols are sometimes interchangeably usable, but I think are really complementary. And I think MQTT is one of the most popular, or it's the most popular IoT protocol out there. And I do think this will still remain, but MQTT-SN will even help adopt the MQTT or increase the MQTT adoption across the industry, because now you can go from this small sensor networks or this low power wide area networks and then connect it to the MQTT world. And this is, I think, is really great. And so I do see a bright future for MQTT-SN.
Just to add on what Dominic said there, I mean, we've already seen with our customers huge benefits from going down the SN route versus a full-fledged TCP/IP stack. So yeah, it's really already delivering results for us, and I see it as things expand and as it becomes more widespread. I think yeah, it should be everywhere.
What a beautiful place to stop. Again, thank everybody. We are thrilled with the amount of interest in MQTT-SN. We will follow up and answer your specific questions. I would like to thank my assistant, Jane Harnad. Thank you so much for all your support, and of course, our wonderful speakers. Thank you so much for joining our webinar today. Have a beautiful afternoon. Bye, folks.